Okay, so in this section here, we're going to be working with functions, right, and finding input and output values, right, depending on what is given uh, to us, right. So here we're going to look at algebraically, right. If we're given a function, how do I evaluate, right? So again, from previous section here, we have function notation, right? F of x, right? And again, it doesn't have to be f. I think f is usually the standard, but because we're thinking of a function, but it could be g of x or even g of n, for example, right? Again, these are just arbitrary words, right? The x and y we usually think of standard when we're graphing in terms of the x-axis, y-axis, right? But again, right, when dealing with function notation, especially if we're doing our application problems, right? If the function and the input variable, the independent variable, if they're use letters that are more descriptive of what they represent, then it might be easier, right? But for now here, for this one, we're just looking at an algebraic approach to evaluating. We'll use the notation f of x, right? So let's say f of x is equal to x squared minus 5. All right, so here we have a function where the independent variable is x, so we have x squared minus 5. And let's say we were asked to evaluate the following quantities. All right. Evaluate the following quantities. All right, so let's say A, I want to find, let's say, f of 4. B, I want to find f of A. And then C, we'll look of f of A plus h. Okay. All right, so let's start with A, right? That was pretty straightforward. We replace x with the number 4. All right, so for A, like f of 4. Right, so the way you want to interpret that is wherever you see an x, you now replace that with a 4. So here we'll have 4 squared minus 5. Right, and this equals to 16 minus 5, and that equals to 9. Oh, excuse me, forgot to do my arithmetic here. 11. All right, so 16 minus 5 equals 11. All right, and that is what f of 4 is equal to. Right now, as you're working on your own kind of work here, this is what I want to see. I want to see you guys working vertically. All right, too many times I see students working to the left, and it's just not easy to read, especially when we're working with equations and you're working off like, and you're starting to work on both sides, but you keep working horizontally. So let's keep it nice and clean and work vertically here. Okay, all right, now let's take a look at B. All right, so for B, now this one they changed it up on us, right? It looks like, well, they just changed an x with an a. It's not a number. What do I do with that? Well, let's start off the same with the way we did up here, right? Wherever you see an x, you replace it with, in this case, a, right? Whatever is in there. So we got a squared minus 5. And I don't know what a is. A is some unknown value, right? There's no other information there that is telling me what a is. So there's only one thing I really can do is rewrite this like this, a squared minus 5. Okay? And that is it, right? It looks like we didn't do anything. Well, we just evaluated what they gave us, right? In this case, a, right? It's a function of a, whatever a represents. Okay? All right. So now let's move on to C here. Here they ask us to evaluate f of a plus h. Okay, now again, right here, these are a and h, some unknown values. The only thing we can do here is, again, these come together, right? It says wherever x is, replace it by this quantity, a plus h. So here we have a plus h, that whole quantity, squared minus 5. Okay, All right, now here I can do a little simplification. Be careful here. All right, how do I simplify this? What does square mean? That means a plus h times a plus h minus 5, right? This is not a squared plus h squared, right? Unfortunately, it does not work that easily, right? So here we have to do our FOIL, first, outer, inner, last. A times a squared. The outer terms are a and h, right? Again, I don't know what those are, so we just leave them as ah. H times a is ha, but I'll write them as ah just to see that those are in fact like terms. And the last term is h times h squared minus 5. All right, and I'll combine any like terms that I see. Remember, in order for them to be a like term, they have to consist of not just the same variable, but the same power for all the variables. So in this case, I only see one, or a pair of like terms, excuse me, these two. So there's one here and one here for a total of 2 AH. All right. And that is how we go about evaluating something like this, right? Okay. All right. Now you may think that, oh, this seems like a bit abstract. What is it that we're doing? It, and it is a little bit more abstract. What we'll see later in future math courses, in this case calculus, we see that this quantity, a plus h, is going to represent something very important, right? But for now, we'll just kind of leave it as is here. All right. So that's how you would evaluate at a given value. Right, now let's say they change the problem on us, right? So let's say in this example, there we go. Let's see here. Let's say in this example, let's say we're given g of m equals to the square root of m minus 4. Then solve for g of m is equal to 2. Okay. All right. Now first, let's notice here, how is this different from what we're doing previously, what we did in the previous example? Well, in the previous example, they gave us our input value, right? It says, here's 4, and put it into our function. That is not what we have here. Right now, if you look here, m is the input, but I don't know what m is. What do I know? I know the output, right? So in this case, how this differs from before is that we know our output value, right? In this case, our output value is 2. Okay, so what is this saying, right? G of m is equal to 2, right? But g of m is also equal to square root of m minus 4, right? So I can kind of, here doing a little substitution here, I could set these two equal to each other. We say 2 is equal to the square root of m minus 4. All right, and again, notice, why can I do that? Well, both of these are g of m, right? G of m is equal to 2 in this instance, but g of m is also equal to the function square root of m minus 4. All right. Okay, so here we have this function here. So now what it's asking me for, when it says solve, what is the input value that gives me this result? All right. So in this case, what the problem now becomes is find the input value. The input value m. Okay. So here I could say, all right, square root of m minus 4, how do I solve for m? Now I can't jump directly to the 4. Right? Think of these as, well, I have to work my way from outside to inside, right? Before I can like add 4 to both sides, I have to figure out, well, what do I do with that square root, right? Well, the I guess inverse operation here would be to square both sides. All right, looking at this, we say, all right, well, I can counteract that square root by squaring both sides. Remember, as long as you do something to both sides of the equation, you're good. So this on the left here will have 4. And on the right, the square counteracts the square root, and we're simply left with m minus 4. Right now I've worked my way outside of that outer shell you can think of with the square root, and now we're left with m minus 4. And from here, and just add 4 to both sides, and we get 8 is equal to m. Okay. And now that value, that input value, gives me a result of 2. So I have completed my example. Okay, so one other example we're going to do here is, let's say that we're given a relation. All right, and then we're asked, let's say in this example, we were given, let's say we're asked, does x squared plus y squared equal to 9 represent a function with x as input and y as output. Okay, here in other words it's asking me, well, can I solve for y, right? And in that solution, do I have a function? Okay, so let's go ahead and do that, right? So we know it's a relation, right? For sure this represents any ordered pairs where you square x, you square y, and it's equal to 9. Right, that's what this function is representing. Okay, excuse me. Should not say function. Don't know whether it's a function. This relation represents, you take the first input, you square it, you take the second input, you also square that, and if you add them up and get 9, then you have yourself a function. Excuse me, you have yourself a relation. Okay. All right, you have yourself an ordered pair for the relation. So let's go ahead, let's solve for y right here. All right, so in other words here, what it's asking me for is solve for y. Okay, so start off here. Let's start off by, again, isolating the y. We'll first start off by subtracting x squared. All right, we had 9 minus x squared. Okay, and again, similar to our previous problem where we had the square root and we squared it, here we have a square. So to counteract that, we take the square root. Now, here, we must be careful whenever we're taking the square root of a square, right? Now, the reason for that is because of the nature of the square, right? Let's say if we have, as just an aside here, let's say we had this quantity, right? Let's say x squared is equal to 16. All right, and we'll say, all right, I'll just take square root, and x is equal to 4, right? But that's not all of it, right? If we have something like this, negative 4 also satisfies this equation, right? Negative 4 squared is negative 4 times negative 4, which is a positive 16. Right? So as it turns out, whenever we take the square root of a square, we have to make sure that we always, right, always add that plus minus. Okay, or else we kind of ignore a solution. So I'm going to do that here, right? Take the square root of a square, and we have plus minus, right? Don't forget that. So we have y is equal to plus or minus square root of 9 minus x squared. All right, well, what does this mean, right? Plus minus. Well, that means that y is equal to the positive part, 9 minus x squared, or y is equal to the negative part, negative square root 9 minus x squared. All right, so now going back to our original question, does this represent a function with x as input and y as output? And the answer is no. Right? No, it represents two functions. Okay, this being one function and then the negative part being the other function. Okay, all right, and that's how we would go about answering a question like this, right? Whenever you see something, does it represent a function with x as input and y as output? All it's asking you is solve for y, and do you get, as a result, just one equation where we have y is equal to some expression, right? Remember, this expression cannot have any y's. Right? If it does, then you have not completely solved for y. Right, thank you.